Well, welcome back. I'm Mr. Eicher. We're going to do part 2 of our lesson on logarithms and solving logarithmic equations. So let's take a look. To solve logarithmic equations, use the definition of a logarithm. This is brand new for you, other than the very last video you learned it. But if you have log base b of a equals e, we can rewrite that as the base raised to e the exponent equals the answer. We do have to be careful about extraneous solutions since negative numbers are not in the domain of log functions. So let's check out number 1 here. We can rewrite this as the base, this is our answer, and this is our exponent, bacon and eggs. So we have 25 raised to the exponent of 3/2 equals n. And from the last chapter, we learned that if you have a rational exponent like this, the 2, the number under the in the denominator there, we can rewrite as a 2th root, a square root of 25 cubed equals 3. So that would be 5 cubed equals n. I think I said equals 3 on the previous one, but I meant equals n. So 5 cubed equals n. So n would be 5 times 5 times 5, so 125. To make sure this is not extraneous, we would plug in here 125, and as long as it's not, it doesn't give a negative answer, log of a negative number, then it's okay. So this is an okay solution. It's not extraneous. Let's look at the next one. You have log base 10. So we can rewrite this. Let's label these. This is our base, answer, and exponent. So we would have the base is 10, the exponent is 1, and that equals x squared plus 1. And we solve this for x. So we'd subtract 1 from both sides, and then we would square root both sides, and make sure when you square root both sides you get plus or minus square root of 9. So we have 2 possible answers, a positive 3 and a negative 3. Now to check if they are extraneous, when you plug in here a plus or a minus 3, do we get a log of a negative number? Well, actually, no, we don't, because 3 squared plus 1 and negative 3 squared plus 1, both of these are positive 10. So log of a positive number is okay. We get 2 answers, positive and negative 3 for the value of x. Some students get confused here because they'll say, hey, I thought you said a negative wasn't allowed up here in the directions about negative numbers. That's true, but that's when you evaluate the entire log. So like if you did log of negative 3, that would be undefined. But that's not what we're doing here. We're doing the log of negative 3 squared plus 1. So we're really doing the log of positive 10, and that is a defined answer. Let's look at number 4. We can rewrite this. Here's the base, the answer, and the exponent. So our base is 8, our exponent is 4/3, and the answer we get is n. We can rewrite this as a cubed root of 8 raised to the 4th equals n. The cubed root of 8 is 2 to the 4th equals n. 2 to the 4th would be 16 is n. Plugging 16 in for n here, that would be a log of a positive 16, so that's okay. We have n is 16 as our answer. And then lastly, we'll do number 6. You'll do 3 and 5 as part of your try this. So if you'd like to pause the video and do them now, you could save yourself some time later. But for number 6, we would write this. We have our base, the answer, and the exponent. So we can rewrite it as base of 2 raised to the exponent of 3 equals x squared plus 2x. 2 cubed is 8, x squared plus 2x. And then to solve this, we could complete the square. We could subtract 8 from both sides and then use quadratic formula or factor. I think I'll try to factor, subtract 8 from both sides. What are factors of -8 that will add to 2? So 4 times -2, 4 plus -2. Looks like we would factor it to be x times x is x squared plus 4 minus 2. So we would get two possible answers: x is -4 or x is +2. Plugging these in to the original question here, we just want to make sure we don't get a negative number. So if we plug in the 4, we'd have -4 squared plus 2 times -4. That would be 16 minus 8 is 8. That's not positive, so that's okay. That's a good answer. And when we plug in 2, we would get 2 squared plus 2 times 2. And that's also a positive. So both of these are legitimate answers. Neither one of them is an extraneous answer. So that's solving logarithmic equations. Let's move on and look at some inequalities. We're going to have an issue with some inequalities. So this says if b is greater than 1 and x is positive, then the log base b of x greater than y is the same as x greater than b raised to the y. So basically what we've done here is we've rewritten it. We keep the x greater than next to each other, and the base moves to be a base on the y, and that is what gets rid of the logarithm. However, if you have a less than log base b of x is less than y, you have this issue of needing to state that x has to be between two numbers. And that's because a logarithm is only defined for positive values. So let's see how this works. For number 7, we can rewrite this. This is log is greater than. So we can rewrite it like this. So we'd have x is greater than the base of 3 raised to the 4. So x is greater than 3 times 3 times 3 times 3 is 81. All the x's greater than 81 would be logarithm of a positive number. So there's no extraneous issues here. That would just be our answer. X is greater than 81. So if we did a little number line, 81 is here, open circle, greater than 81, we're everything over there. You'll do number 8 as a try this. Number 9 is one with one of those less than issues. So we'd rewrite this as, kind of like this right here, we rewrite this as x is less than a base of 2 to the 4, but also it needs to be greater than 0. So when we solve this, x has to be between 0 and 16. So here's 0, here's 16. They're both open circles. X has to be between 0 and 16. That's because if you had a value that is less than 0, a negative number, that would be making it a log of a negative number, which is undefined. So that's why we had to kind of make sure that our solution set didn't include any numbers that would make it a log of a negative number. Let's move on to our last page. Our key concept is if you have log base b of x equals log base b of y, that would be the exact same thing as just stating x equals y. That's because if we raised both of them with a base of b, the log base b and the base of b would cancel, and you'd just be left with x equals y. So typically these are your students' favorite type of question, because if you have a log base 5 and a log base 5, those log base 5s cancel and you're left with the stuff on the inside equal to each other. P squared minus 2 equals p. And then you just have to figure out how to solve that. So if you'd like to pause the video and see if you know how to solve that, go for it. Best idea, I think, would be subtracting p from both sides, and then you can factor. P times p is p squared, 2 times 1 is 2, and you need it to be a negative p on the inside. So we get p equals 2 or p equals negative 1. Are either of these extraneous? The concern would be here. If you plug negative 1 into here, that would be undefined. So really this negative 1 is extraneous. The positive 2, however, when you plug it into either one, you're going to get log of a positive number. So you only have one answer, p equals 2. I'd encourage you to pause the video on number 11, see if you can figure that out. Number 11, we have log base 2 on both sides. Those cancel. So you just have x squared minus 4 equals 3x. And we'll solve it kind of like the last one. We're going to subtract 3x from both sides and then factor. X times x is x squared. 4 times 1, you need it to be a negative. So we have two possible answers, and it looks like this one, when you plug it into here, that would be log of a negative 3, which is undefined. And that's a problem, making this extraneous. Our only answer is x equals 4. And then you have number 12 as part of your try this. And the last two questions, you'll do 15 on your own. Last two questions, we just have some inequality issues. So we have if log base b of x is greater than log base b of y, that's true if x is greater than y. If log base b of x is less than log base b of y, that's true if y is less than x. Sorry, x is less than y, I said that backwards. So solving these, we would have 4y minus 10 is greater than or equal to y minus 1. Subtracting y from both sides, adding 10 to both sides, we get y's greater than or equal to 3. We don't have any extraneous issue here because plugging 3 into both of these, or any number greater than 3, we'd have log of positive numbers. So this would be our answer. If you'd like to include the graph, it would be a shaded circle greater than 3. And then lastly, for number 14, log base 4 on both sides cancel. You have x plus 3 is greater than 2x plus 1. Subtract x from both sides. Subtract 1 from both sides. Flip the inequality, so x is first. So we have x is less than 2. This one we have to be careful about because there are certain numbers that are less than 2 that if you plug into either one of these, you're going to get a log of a negative number. So really both of these quantities need to be positive. So x plus 3 needs to be positive, and 2x plus 1 needs to be positive to be defined. To be defined. Both of these have to be true. So that tells us that x has to be greater than negative 3, and x has to be greater than negative 1/2. So if we think about this, where our extraneous possibilities are, if we look at a number line, here's negative 3, here's negative 1/2, here's our answer of 2, that answer right there of 2. We said we needed x's less than 2, but we also said we needed x's that are both greater than negative 3 and greater than negative 1/2. So whichever one's closer to your solution, which would be the negative 1/2, that's the one that you use to say our answer has to be between negative 1/2 and positive 2. If you wrote that in interval notation, it would look like this, negative 1/2, comma 2, in both parentheses since they're both open circles. You'll try out number 15 as part of your try this. Thanks for watching this video, and I'll see you next time.